Hi guys, welcome in. So today we're doing a reteach of the exponent rules that we've been discussing in class. I know some of these are a little bit tough, but I think we can get through them pretty easily today in class. Okay, so the first one, whenever we have a situation where we have the same base, so in this case x, and then raised to different exponents and we're multiplying by each other, we're allowed to just add those exponents together. So, for example, if we had, let's say, 5 squared times 5 to the 7th, we are allowed to write that as 5 raised to the 2 plus 7. Now what's 2 plus 7? 9, right? So 5 to the 9th power. Why does this work? Well, if we have 5 squared, that's really saying that we have like 5 times 5, right? 5 times 5. Awesome. All right, if we have 5 to the 7th, or so times, and then 5 to the 7th, we're going to have 7 5s. 1, 2, 3, 4, 5, 6, 7. Okay? And now how many do we have total after writing all those out? 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 to the 9th. It holds true. Right? So that's how that rule works. So you can write it in extended form and then solve it out if that helps you. If the adding together just isn't feeling right, write it out. I encourage you to. I think that's a great method. All right. So then on to the next one. All the erasing. Okay. All right. So then the next one, if we have a fraction where we have the same base, we can almost like subtract them from one another, and we can use our big one method to simplify it. So let's say we have 2 to the 5th over 2 to the 2nd. Well, our rule just says we can subtract them, so we can write it as 2. And then since our big number is in our numerator, we can just write it as 2 to the 5 minus 2. Or 5 minus 2 is 3, right? So we can write it as 2 to the 3rd. And why does that work? So if we write it in expanded form, I'm going to put my fraction bar here. 2 to the 5th is 2 times itself 5 times. 2, 3, 4, 5. Awesome. And 2 to the 2nd is 2 times itself 2 times. 1, 2. All right. So then if we look at this in terms of division, right? What's 2 divided by 2? Well, that's just 1. And what's 2 divided by 2? Again, that's 1. And now any number times 1 is just itself, right? So all that we are left with is 2 times itself 3 times. Hey, guess what? That's 2 to the 3rd. We got it. Okay? So that's what we're allowed to do. All right. Last but not least, there's 2 more to do. All right. So our next one is whenever we have exponents with the same base and then there's a parentheses and an exponent on the outside, we're essentially allowed to like kind of distribute, really. So for instance, if I had an example of 2 squared times 2, or 2 to the 2th squared on the outside, what I'm allowed to do is write it as 2 and then to the 2 times 2, which is really 2 to the 4th power. Okay, so how does this work in expanded form? Well, I have 2 squared, right? So 2 squared is 2 times 2, right? And now this squared on the outside is telling me, hey, I need 2 of those multiplied by each other. So I'm going to have 2 of those groupings, 2 times 2. Now, in total, how many 2's do I have multiplied by each other? Well, 1, 2, 3, 4. I have 4 So therefore, it's 2 to the 4th, okay? So make sure that you guys expand out your group, your first group that's in the parentheses, and then make those parentheses for however many exponents you have on the outside if you're writing it in extended form. Or you could also think about it, you guys remember like the distributing property, right? You're kind of like going to distribute this 2 exponent to the 2 on the inside, to the exponent on the inside. So, and distributing is multiplication, right? So 2 times 2 is 4. All right. Last but not least, this is probably the weirdest rule, but I promise you it will always work. If you have a negative exponent, so for example, 5 to the negative 7th power, that is super ugly. We don't like negative exponents. They don't make sense. We're not a big fan of them. But we can always write negative exponents and we can convert them into positive exponents by putting them in the denominator. So we're going to make a fraction bar. We're going to put 1 on the top. We're always going to put 1 on the top. We're always going to, in the denominator, put our same base. So our base is 5. We're just going to keep our base of 5. Then all we have to do is take our exponent and make it positive. So these two are indeed equal to each other. And we talked about why in class. I'm not going to go over that today in this video. But for our purposes here, this always works. And you guys can always simplify this way. So any base to a negative exponent is equal to 1 over same base and then the positive of that exponent. All right. Good luck on your skill check, guys, and I'll see you later.